Good morning students, my name is Anil. Today we are going to discuss different types of reactions. The first one is combination reaction. So how we define combination reaction? In combination reaction, two or more reactants react together to form a single product. Two or more reactants react to form single product. For example, Mg plus O2 give 2Mg. Okay. Next example we can take 2H2 plus O2 give 2H2. Now you can see two reactants, they are changed into single product. So we can say an example of combination reaction. The next type is decomposition reaction. Decomposition reaction is opposite of combination reaction. So how we can define that? In decomposition reaction, a single reactant break down into two or more products. For example, CaCO3 will give on heating CaO plus CO2. In this reaction, you can see a single reactant break down into two or more products. So this is an example of decomposition reaction. Another example we can take 2FeSO4, which will give Fe2O3 plus SO2 plus SO3. Yesterday we discussed about this. FeSO4 is of green color, and after heating it will change into brown Fe2O3. Next example of decomposition reaction is electrolysis of water. On electrolysis of water, we get hydrogen gas and oxygen gas. And one more important example of decomposition reaction is AgCl. To AgCl, in presence of sunlight, it will decompose to give to Ag plus Br. So these are the four examples of decomposition reaction. A third one is displacement reaction. So how we define displacement reaction? So displacement reaction in which a more reactive element can displace a less reactive element to form a product. So in this we can say a less reactive metal, you can say metal is displaced by high reactive matter. For an example, CuSO4 plus Zn will give ZnSO4 plus Cu. Copper sulfate color is blue, and when it reacts with zinc, we get a colorless solution. Another example of displacement reaction, CuSO4 plus Fe, blue color, Fe iron, it will give FeSO4 plus Cu. FeSO4 is a green color. So in this reaction you can see copper is displaced by zinc. Copper is displaced by zinc. That means zinc is more reactive than copper. And in this reaction, copper is displaced by iron. That means iron is more reactive than copper. So now the definition is according to this: less reactive metal is displaced by high reactive metal. So more reactive metal displaces the less reactive metal from its compound. The next type of the reaction is double displacement reaction. Double displacement reaction. In double displacement reaction, two compounds exchange their ions to form two new substances. So we can define two compounds exchange their ions to form two new substances. So this is displacement reaction. So example of double displacement reaction: BaCl2 plus Na2SO4 give NaCl plus BaSO4. So this is an example of double displacement reaction. It's an example of double displacement reaction. Now you can see we have barium chloride and sodium sulfate. So barium chloride and sodium sulfate exchange their ions to form new compounds, sodium chloride and barium sulfate. Next type is last one, the fifth one, redox reaction. Redox reaction. So what is redox reaction? In redox reaction, in this type of reaction, both oxidation and reduction take place at the same time. So what are the redox reaction? In redox reaction, reduction and oxidation, both reaction take place at the same time. So that reaction we call it redox reaction. So first of all, we will discuss what is oxidation. Oxidation means addition of oxygen and removal of hydrogen. And what is reduction? Addition of hydrogen and loss of oxygen. For example, you can take CO plus H2. we get H2O plus Cu. Now we can see CuO will change into Cu, copper, and hydrogen H2 will change into H2. So from here we can see easily CuO loss of oxygen atom to change into Cu. So loss of oxygen atom, loss of oxygen is taken as reduction. And here you can see hydrogen gain oxygen atom to change into water, H2. So there is a gain of oxygen, so it is a oxidation reaction. So in a one reaction, both oxidation and reduction take place. So this is an example of redox reaction. After discussing different types of reaction, the last topic of this chapter is effects of oxidation. Effects of oxidation in everyday life. So we will discuss here on two important effects of oxidation. First one is corrosion of metals, and second is rancidity of food. Two main effects of oxidation. First one is corrosion of metals and second is rancidity of food. Let's discuss each and every one. So corrosion of metals. In corrosion of metals, the upper layer of metals is oxidized by the action of water and oxygen, and it changes into rust by the action of water and oxygen. The upper layer get rusted. For example, now we discuss rusting of iron. Fe plus oxygen 2x H2 will change into 2Fe2O3 dot XH2, iron oxide, rust. So iron when react with oxygen and water, it will change into rust. This process is known as corrosion of metals. We will discuss more about this in third chapter, metals and non-metals. The next topic is rancidity. So what is rancidity? When oily or fat containing food oxidize under oxidation, it gives unpleasant smell. And bad taste. This is known as rancidity. So what are the different methods to prevent rancidity, or how we can prevent rancidity? The first one is by adding antioxidant. What are antioxidants? These are chemical substances which prevent oxidation of food, like BHA and BHT. These are antioxidant substances which is added into the food to prevent oxidation. Second, by filling nitrogen gas in potato chips, etc., to prevent oxidation. Third one, by keeping the food at low temperature. when we keep the food at low temperature, the process of oxidation gets slowed down. Fourth one is by keeping the food in airtight container. If we keep the food in airtight containers, so we can prevent oxidation. And the last one is, fifth one, by keeping the food away from sunlight. If we keep the food away from the sunlight, the process of oxidation can be slowed down. So these are the 5 different methods by which we can prevent rancidity.